Okay, so in this video we're going to be looking at how we can inspect the value of the minimum or maximum of a parabola. So in order to do this we need to graph a function, and in this case we're going to be graphing a quadratic polynomial here, which has an a value that's a positive value. And because that a value is positive, we're going to get a convexing parabola, and it's going to have a minimum. So we're going to press y equals, and we're going to press the x button there, and we're going to just enter x squared plus 3.5. Okay, and we're going to hit graph. And in this case, we actually need to resize our window because it's not appropriate. So we go to window, and we need to try and make sure that our y-max is of a decent size, so I'll probably go 10. And it's always good to actually look at a parabola on the other side of the y-axis as well, so we're going to put negative 10 in there. And as you can see, we've got our quadratic there. So what we do now is we click second function, calculate, and we go down to minimum, and we just want to go to the left bound, so we use the left arrows there in order to move the cursor, and we need to go to the right bound. The reason we do this is because on higher order polynomials we will actually have more than one turning point, and we need to tell the calculator which minimum we actually want. So here you can guess what the value is, but we're just going to go ahead and press enter, and it tells us that the minimum value, or as you can see here, it's generally meant to be when x equals 0, but in this case it's showing a very small number just because of the calculator program. But when x equals 0, so on the y-intercept, we get our minimum. So at the point 0, or a very low number in this case because of what the calculator is telling us, comma 3.5 is the coordinate point there. But what if we don't actually have a minimum? What if we have a maximum to a parabola? So what I'll do is I'll just go back to the y equals menu here, and let's say that instead of having this we had, I'll just clear the entire thing here, negative x raised to the power of 2, so again it's still a quadratic, plus 6x plus 4. So let's say we had that. I'm just going to go ahead and hit graph here. And as you can see, our maximum's off the screen again, so we're going to have to go to window, and we probably want to change our y-max value. Probably double this to be 20. So as you can see, we've got our parabola there. This time it has a maximum. Well, very similar process. We go second function, calculate, and we scroll down to maximum. And again, same story, we go left bound of the turning point, so I'll just move the cursor to a position left of our maximum. And then we need to go right bound, so again we move the cursor using the right arrow key here. And once we're to the right of it, we just press enter. We don't want to guess, so we just press enter again. And it tells us that our maximum is at, well, the equivalent of 3 here, and that gives us a y-coordinate of 13. So if we were to write this as a coordinate pair, it would be 3, 13. So that's how to actually find the minimum and maximum values of a particular quadratic or other polynomial, depending on what you're actually looking at. Again, it's really simple and straightforward. You just need to choose the right function and ensure that your window size is appropriate. That's all for now. Thank you for watching.